Hello everyone. This is Rishikesh, and today I'm going to solve the Leetcode problems with you all. And I hope you guys get idea about how I am solving the problems, and will you can also solve simultaneously while watching video. Okay. So now let's get started. And the questions will be totally random. I'm going to pick from a driver's seat. Okay. And the question will going to be totally normal, and the most important thing about this session is that uh, I'll pick the hard ones that is actually hard, uh, not an easy one that you can directly solve here. Let's get okay, let's open the okay, close some tabs. Yeah, close some tabs. Open the driver DSS. I'm not going to solve from the A to Z sheet because in A to Z sheets there are multiple questions that we do not need to solve all of them. And in the SD sheet we have some filtered questions that are filtered from A to Z sheets, and that are just 191 questions. So we can in a 2 to 3 month of duration we can go through all of that question, so that I chose to go from Striver STs. Okay, now let me check why it is not working. I just throw my phone so that just a second. Yeah, what I did, I can open from here. Where is YouTube? Where is YouTube? Yeah, I can open it from here as well. Close web tabs. Let me check that am I correctly live or not. If I'm not, then I'll try to figure out what are the issues that are coming if I will live. Then we can continue. Not an issue. Why it is so much lagging? Mm, that is the major problem, guys. It is not even how can we do something? Am I live or not? Channel. I hope I am. I should live. Yeah. But I don't know why internet is not working. Let me check what is the speed of the internet online. Mm, Speed test. Let me go to a speed test. Go from driver STs. Okay. Now let me check why it is not working. I just throw my phone so that. Just a second. Just a second. Yeah. What I did. I can open from here as well. So that is fine. That is fine. Where is YouTube? Where is YouTube? That is fine. Not a big issue. I think due to internet connection, it's a bit slow, but okay. What will happen? Going to happen in 9 minutes. Rath Yatra. Rath Yatra offer is live. I don't know why this is giving offers all the time. Let me go through. Go with binary search. I'll pick one question from dynamic programming, second one from graph, and third one from binary search. Okay, let me write it. Mm, any note notion. Notion work notebook. At time doing notion work. Why it is taking so much of time? So let's pick up a question from dynamic programming, and then after solving that particular problem, we'll move forward with the graph, and then binary search tree, and then a stack and queue. Okay. So firstly, let's go with the dynamic programming. Let's edit distance is looking good. Okay. Okay. Actually, I have not even idea that how what is inside this problem edit distance in which topic in which how would be the approach for solving this particular problem, but I'm going to try with this uh, assuming that this is a newly questions, and I'll think how to solve this with you all, and then we'll get idea about how to solve this. Okay. It's taking a lot of time and why. Edit distance. Actually, if I remember something, what should be the state? Yeah, I already solved, but I don't know how. Okay, given two strings, word one and word two. Okay, correct, got it. Return the minimum number of operations required to convert word one to word two. You have the following three operation permitted. Insert a character, delete a skip. So the questioning is saying that uh, we have to, you can say that how long this also is. Oh my god. Oh my god. Do not uh, think about anything, just read this. Um, we have given two strings. String one is word one, and second one is word two. Return the minimum number of operations required to convert word one to word two. Actually, we can insert a character, delete a character, replace a collection or a character. Return the minimum operation required to convert word one to word two. So we have to do all the operation on the word one, not on the word two, right? So actually, we can edit anything in word one. Word is coming. Yeah. So we can edit any character from word one. We can delete any character from word one, and we can replace any character with any character in word one. We have like three operations there. Uh, we can use that and solve it. I'm taking this screenshot and up to two examples and going to open in the Excel drawer to tell me what I am thinking. Okay. It's working correctly. This is the problem example. Let's see that what we can do here. Yeah. Mm, it should go. Right. Somewhat. Mm, okay. So we have. Yeah. We have a horse. Okay. We have rows. So firstly, like HORSE. Okay. SE. And second one is rows. Rows. Kind of. Got it. So, what we can do is that we can't directly like compare this R with R, you know, for comparing R, we need to like delete on these two, and again for O, for S, we have to like do again two operations. So it is not a greedy kind of approach. It will not gonna accept with this. So we have to think about other approach that should work. That should work, and what we can do here is that we have R like, and we have H. Okay, so so if that is not matched with this one, okay, then what we can do? Either way, we have to remove that, right? Either way, we have to remove that, or either way, you have to replace that, or even though you can delete this as well. Like if it is not matched, then we have to do like things. And for we we have not even a idea that what will going to happen in the next indexes, so we can't assume that replacing will going to find the optimal answer, or deleting will going to give the optimal answer, right? So what we can do here is that we need to mm, yeah, we need to do all the operations that are possible in as simple as that. We have three operations: replace, remove, insert. Okay, right? So we can do all the operations as simple as that. H and R that is not matched. Okay, then in a way that we can, what we can do is that we can uh, replace this character. So what will happen in the replace? If you consider replace, then what will going to happen? We assume that H is converted, right? H is converted with R. But let me again explain that. If we were considering replace, right? If we are considering replace, then we can think that H is converted to R. It means that both the both are equal, like we matched kind of. So we can increase a index, we can like increase a index from both the strings, you may understand. So we are assuming that it is converted into R, so that we can move the pointer from previous index to next index here as well, or this pointer is also moved to here, right? I hope you can understand. I hope you will understand that what I am trying to say. Okay, and so firstly we did R, and if we choose a replace, then we need to move both the pointers, right? Then only it is good. Let's suppose we don't want to like choose replace. We want to delete, right? We want to delete. What will going to happen in this particular case? If we want to delete this H, then this above pointer will going to point to the next character, but the pointer of word 2 is still pointing with the character R. This is what. And the most important thing is that In this case, the first pointer is going to move forward, but the second pointer is still pointing on the R. I hope you may get the idea. So for replace, not replace, for delete, for delete, the first, this will going to point to the next character, right? But this previous pointer is still pointing to R. So yeah, so delete is done, right? Third one is that insert. Insert is also a same kind of thing. You can think that if I am going to insert R over here, okay, so what will going to happen? Our pointer is still pointing on the edge because R is matched. Okay, R is matched, then our pointer is still going to point on the edge, but this pointer R is matched with this R, so that we can increase the pointer of word 2 and we can going to point over here, but the above word 1 pointer is still pointing on the edge. This is too easy to understand, not as much difficult as you think. So yeah, that is done. This is the question. And you may think that whenever we reach on the whenever you whenever pointer of word to whenever pointer of word to reach to index n, then we'll get our answer. Then we can just then we can if their pointer is not reached. Okay, let's suppose word one pointer is pointing on the S, but their word two pointer is reached, right? In this case, we have to delete all these three items from here, even though this also. Okay, we have to delete all these um, three character from the word one so that we can match word one with the word two. So we can return the difference. Okay. Yeah. And what will happen if this pointer is still on here and this pointer reach to the end? Same thing. We have to insert the characters. So if in either word one pointer is reached to last index, or word two pointer is reached to last index, we just need to return how much elements are left from either from word one or either from word two. That is, and the question is finished. Literally, the question is finished. Let me solve it. Let me create a function. Okay. Int I1 index 1, int I2 index 2. Okay. These are the indexes. String W1. Okay. And string W2. Okay. We have two strings and we have a DP array, okay, that will going to store the states. Like we have, you know, only this index is changing. These are constant. So we need to like store the state of the function so that we can't call this function again manipulate the recursive exponential value can store into the DP array, and then we can retrieve from here whenever we need. Okay, if I1 um, is less than equal to 0, okay? Yeah, I2 is equal to 0. Either way is true. I am traversing from back, so do not worry about anything. As simple as that. Okay. So either way, if I1 equal to 0 or I2 equal to 0, then what we need to do? In this way, okay. What I can do here is that, yeah, okay, let's come together. If either this pointer is just to 0 or this pointer is just to 0 index, if both the pointers are equal, then return 0. Otherwise, if w dot char at 0 equal to w2 dot char at 0, okay? If 0, then return 0, okay? Return 0. Like we do not need to do like extra operation on this way. Let me check what are the constraints. 500, that will work, that will work. If double1 dot character is equal to double2 dot character, then we can directly return 0. In other way, if that is equal to, then um, okay. Mm, then return, we have to return mm, I1 plus I2. Okay? It is a bit confusing, guys. It is a bit confusing. Plus one. Let me explain. It is a bit confusing. So let me explain this. So I have a horse. HORSE. Okay. And I have a Rosh. Okay. ROS. And if our word one pointer is on O, okay, and our word two pointer is on R. If both pointing to R, then it will directly return 0, not 0, not 0, not 0. Okay, let me check. So if this is pointing on the 1 and this is pointing on the 0, and then our we have to return to, we have to like delete, replace. Okay, understood. Okay, for one we have to convert it into R. For this we can delete. Okay. But what it is R? So for word one, okay, for word one we have to reach 0, right? Mm, for this one, I think mm, to change that. Mm, 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 yes, if it is a consent, the negative account means we have done, then you just need to return hide. Plus, we have to delete all the elements, right? And if hide is essential, means we're done with hide to we ended this. Okay, then and then this is pointing to s. Then we need to insert to choose return orientation because we need to delete. We need to insert that much of element there. We have three questions. Need to rework, replace, replace as equals to replace is equal to the one plus and we'll get from replace question. This means again enhancement, right enhancement, and then W1, and then W2, and then replace, delete. Delete is equal to 1 plus, we have deleted something. Then we just move by minus 1, but we deleted something now. Okay, I2 is still wanting to write, W1 is still, W2 is still, decrease is still. And mm, same is equals to mm, March same if W1 dot add I1 is equals to 400 add I2, then same is equals to initial by 1 minus 1 comma I2 comma W1 comma W2 comma W. Okay, this is done. Um, replace later on, insert int insert is equals to 1 plus function inserting something, like if we are inserting r, I1 right to means I1 is still I1 is still pointing to, but I2 L1 W1 and W2 DP. Okay. Into maths, equals to math dot document was same comma update into is equals to math dot mean or del comma insert and return dp of given right to is equals to math dot mean two. Okay. If if different 5 minus from minus 1, then return okay, got it. Then I think mm, and I1 is equals to what it mean what then I1 is equals to what to star star BP is equals to I1, right. Okay. Then our and is equal to I1 0 plus I is equal to 1. I1 plus I plus second is to figure and repeat I comma minus 1. Return function of I1 minus 1 I2 minus 1 or what 1 what 1 what would it be? I hope this will work. Yeah, yeah, yeah. Done. And what I did previously, in all submissions, how much big could I have written? 1 year. And done. Mhm. This is the bottom approach, right? Okay. Now moving forward, I'll let me check and I'll problem dot del comma insert and return dp of given I2 is equals to math dot mean So let's pick up the another question from graph as I already discussed. So this turn graph from can you do in this guy? Can you do that? Can you do this? Let me check. So let's understand this question and then we'll try to solve and figure out what are the approach going to use. So there are total num courses. Okay, we have num courses, right? Courses you have to take leveled from 0 to num minus num course minus 1 means last course. You are given an array prerequisite where prerequisites I is equals to AI comma BI indicates that you must take course B1 first if you want to take course A1. Simply it is saying that if you want to do any course, then you we have to like do their prerequisite course, then only we can do like that course. Okay. For example, the pair 0 comma indicates that to take course 0, you have to firstly take course 1. Return true if you can finish all the courses, otherwise return false. This is one of the simplest question that I ever seen. We just need to find that is there any cycle present or not. Let me check. Let me come here. Come. I'll explain. So basically, we have course 0, we have course 1, we have course 2. And saying that for purchasing course 1, we have to we have to firstly purchase course 0. Means if you want to purchase one, then you should firstly purchase 0. If you want to purchase 2, then we have to purchase 1. And if you want to purchase 1, then firstly we have to purchase um, like 0, 1. If you want to purchase, yeah, what is written in the question? Um, because to take course 0, we have to first take course 1. To take course 0, okay? Take 0. We have to firstly take 1. Means firstly take 1, then only you can take 0, okay? I hope you may understand. Okay. Mhm. So what we can do is that, like, if we have a lot of things uh, before, like we have 0, okay? 1, 2, 3, 4, 4 courses, and written that before doing course 2, mm, to take course 0, you have to first take course 0, 1 indicates that to take course 0, you have to firstly take course 1. Okay, means 0, 1. Then we have to take course 1. For this one, we have to do course 1. Okay, you managed. For doing 0, we have to do course 1. To take course 0, you have to firstly take course 1. Okay. So to take course 0, we have to traverse all the nodes. Okay, and then check whether will end. We should end, right? If you see the question, to take course 0, we have to take course 1. Okay. For the course 0, we need to purchase the course 1 firstly, then only we can do the course 0. If we say that for course 1, we have to do the course 3. Okay. And then somehow for course 1, we said that we have to do course 4. Okay. Yeah. And for 3, for doing that, we have to do 4 course 4. Okay. That is also good. Mm. So here we can easily do this using DFS. From whenever we are going, you know, just mark that node as a visited. Okay. Like if you're going from 0 to 1, then mark that as visited. Okay. Visited. Going 1, mark 1 as visited. Going child 3, mark child 3 as visited. Going child 4, mark child 4 as visited. We can't go anywhere. If we again reach the visited node, then we can say that we found a cycle kind of things. Again, going back, mark that 4 as unvisited. Okay. Again, mark 3 as unvisited. Again, going to 4, then this is already unvisited. Okay. Then if this looks like this kind of, then we find a cycle here. You can clearly see that. Okay. So in this case, we firstly mark that one as visited, 3 visited, 4 visited, and again one as visited. So again, from going from here to here, we seen that one is already visited. Okay, that is why. Mm, yeah, that is the way we can find out whether our cycle is exist in that particular um, graph or not, or the particular sequence. You can see we can just we seen that the DFS approach led to let come to BFS again. Breadth first search. Breadth first. This is the level by search algorithm, right? Where we goes level on level. So for this, let me again write the examples. For the completing course, we must have to complete course 1 before. For the completing one, we have to must complete 3. And one is on to complete 4, and then 4. Station mark is being reached. Hmm. We can do n degree. N degree means number of rows that are coming. Okay. So here n degree is 2. Here n degree is 1. Here n degree is 0. Okay. We can go from here to here. Then here is also n degree 1. Then we reduce their n degree. So how much it will become? It will reduce 1, so it will 0 again. Then again come to here, we reduce to 0. Again going from here to here, we reduce to 0. Again going from here to here. YDFS, we reduce to G. But what if a cycle will exist? Okay, let's see that. This is 4. This is L1, L2. So if cycle exists, then their end degree, was, I think, we have to. So their end degree becomes 1. Their end degree becomes 0. And their end degree becomes 0. Okay. And again going from here to here, their end degree becomes 0. So how can you find that whether cycle exists or not? Mhm. 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 This will. Okay. Let me see. Near-based approach. I'm not wondering how this. I will back. Now obviously we will back very soon. Mm, it's already 60 minutes. Will back. Now, okay.